the global change or the global warming. So this was one possibility that we have already. Global, the large scale mean temperature, mean rainfall is affected by large scale circulation, but we realize that one possibility is that as the temperature increases, the atmosphere has the higher the moisture holding capacity of the atmosphere increases, and the moisture has a lower molecular weight. So as more moisture gets into the atmosphere as a whole becomes, the lower part of the atmosphere becomes lighter, and it becomes more susceptible to instability. So it becomes more unstable. So when the lower atmosphere becomes more unstable because of more moisture in the atmosphere, so instability can be more vigorous and it can produce more heavy rainfall events. So that was a possibility, and so to check that possibility, we actually did an analysis. That is what Dr. Nandkumar mentioned. So we looked at actual observations of rainfall. We have a very good data set over India, daily rainfall data over many years, 100 years now. But we analyzed about 50 years of data during that time. And at every 1 degree by 1 degree, we looked at what are the distribution of rainfall. Has the distribution of rainfall changed? And it turns out that if you do a distribution of rainfall in the recent 20 years compared to the 20 years close to 50s and 60s, then it turns out that the recent, this is a log curve, and the recent, the tail of the distribution in the recent years has become fatter. That means more extreme events. This is the amount of rainfall on this side. This is the frequency of occurrence. So frequency of occurrence of the heavy rainfall events have increased. If I blow this up here, and that you can see very clearly. Blue line is associated with the earlier period, and the red numbers are in the recent period, which means that more heavy rainfall events have started occurring during this very clearly. And in this part of the frequency distribution, the red line is actually below the blue line, which means the low and moderate rainfall events have actually decreased. And that is one reason why the total rainfall has not increased. Whereas, so the instability due to the more moisture in the atmosphere becomes more unstable and it produces a heavy rainfall event. When a heavy rainfall event takes place, it produces locally heating, produces a lot of more convergence. It drains out a lot of moisture in the neighborhood. So the atmosphere in the neighborhood gets dried up. And then it takes some time before this atmosphere is filled up again, and when enough atmosphere is there, it becomes unstable again and it produces another big event. So that is the process by which this thing seems to be occurring. So this season, so even though the mean rainfall is not actually changing, something is happening to monsoon. What is happening is the distribution is changing. So that is definitely. So with that we counted actually number of extreme events during our central India over this box. Every season, June, July, or September, how many heavy rainfall events takes place, more than 10 centimeters a day, and that number has actually increased significantly. If you take how many heavy events more than 15 centimeters a day, that actually has increased more than 2 times over the last 50 years. So there is a very significant signal of increase in the heavy rainfall events. And the low and moderate rainfall events seem to have decreased. So these two things, the low and moderate event decreasing has another implications. The low and moderate events are important for recharging of groundwater. And if low and moderate events decrease, then what will happen is that the recharging will become weaker. And today, as you know, the groundwater is a very serious problem. We have depleted it by various different over exploitation. And nature is making it more difficult to recharge, so we have to be very careful in actually recharging the groundwater today. In fact, we have also found that the intensity of the highest rainfall events have also increased. In other words, suppose we take this season, June, July, or September, any year, and we ask what was the highest rainfall level in the country in that central India. So suppose in 50 years ago it used to be 18 centimeters per day was the highest rainfall level, not more than that occurred. But today, more than 26 centimeters, 26 centimeters rainfall, heavy rainfall, many of them occur. So it appears that there is And there is an increase in the extreme events, both in intensity as well as the frequency of occurrence. So this is a significant signal. Why this is happening? Because we are able to show that the convective available potential energy, that is the convectivity of the atmosphere, that how the atmosphere becomes unstable, that is measured by what is called convective available potential energy. You can calculate that from temperature and humidity data, and you can, we have calculated that over Central India. It turns out that is increasing, that is consistent with what I proposed. And in fact, something called, this is called a convective inhibition potential energy, inhibition energy, and that energy is something that is the large scale circulation which tends to inhibit the convection. There is suppression of convection, large scale subsidence. That kind of effect has also decreased. So both processes actually both these processes help in actually making more and more extreme events. So therefore, that seems to be consistent with. Once that happens, then something else is possible. That is what they ask the second question. Okay, the extreme events are increasing. Then what is happening to the weather? The extreme events come from very small scale processes, relatively thunderstorm kind of it. But they are always associated with weather events like lows and depressions. Now, if extreme events are increasing, their level of energy has increased. The energy level increasing means if there is, and these small scale events are always difficult to predict, and therefore there will be always errors associated with these small scale events. So, does errors can then affect the prediction of weather? So, we asked, so there is a possibility that if the errors from the small scale go to the weather scale, then our weather will become more difficult to predict. We had this hypothesis based on what we have seen. Then we asked, tried to see from data whether that is actually happening. How do we do that? We can actually calculate. So one of my students, these students, they looked at the rainfall time series and using nonlinear dynamical system analysis, we calculate something called Lyapunov exponent. Lyapunov exponent tells me how any small errors will grow, or if there are two states of the rainfall are slightly different, how they will diverge in their evolution. Just to give you an example, suppose today some rainfall happened, and we have history of what happened yesterday, what happened tomorrow, and this rate of change of rainfall from day to day, and the amount, so the gradients, the amount, intensity, evolution, these properties define the state of the rainfall. So you can define the state of the rainfall, and then you can find two very closely different rainfall, and then you ask how they have evolved differently in the over the years. So that kind of an analysis is you can do mathematically, and this kind of initial differences in the initial state can diverge and become large, and the rate at which it diverges gives us the growth of errors. So that can be actually calculated from data. And we did calculate that, and from based on that data, we have something called the error doubling time over different locations. We took several boxes over northern in the central India, and these numbers represents the error doubling time in days for 25 years period in the closer to 1950s, and these are in the 25 years period in the recent 26-year period in the recent years. So it turns out that everywhere you see that error doubling time has reduced. In other words, errors grow faster. So it's almost double there. So that is again consistent with the fact that the extreme events have increased. The errors associated with the prediction of extreme event can propagate to the synoptic disturbances like prediction of lows and depressions, and that will make the prediction of lows and depressions even harder today, even if we have a very good model. So, in fact, the climate change is doing something and making our life more and more difficult. Even though now we'll see that even total rainfall is decreasing, but for a different reason. So, what it means that that monsoon weather has become almost twice as difficult to predict in the recent years. Therefore, we'll need a much better model. We'll need much better initial condition. That means better data, initial data to predict the weather. So the IMD and we are going to have a tough time in the coming years into making the weather prediction. So that is definite. So now let me go to the other problem. So why are these projections? I have mentioned that the projections are not reliable. Why the projections are not reliable?